In this video we're going to look at estimating effect sizes using the package emmeans. And we're going to look at effects of log cortisol values in 3 different populations. So we've plotted the data down here in the bottom right, and we've already seen that we have evidence that the average cortisol values differ between the populations. Now we want to say, what are the values of cortisol in the different populations? And using our base functions, such as summarizing the fitted model, we can get some information about this. The summary command produces what's called treatment contrasts. So it picks a baseline level, in this case population 1, and it reports the estimated value for the average of population 1. And then it reports differences from the baseline to the other populations. So how does population 2 differ from population 1? And how does population 3 differ from population 1? So that's okay, but it doesn't maybe give us what we want to report in a final publication. Maybe we just want to say, what is the average value in population 2 and population 3? Another problem is that we've log transformed cortisol in order to do the analysis, but that's a little bit hard to interpret. Maybe we want to back transform that onto the original scale, and we can't do the back transformation with the base functions. So emmeans is going to allow us to do both those things, and it's also going to allow us to do post hoc testing, which we'll look at in a future video. So I'm going to load up the emmeans package, and I'm going to set up emmeans by telling it the fitted model that we're going to do the estimates from. So that model is called M1, and I'm going to tell it which explanatory variable do we want to make estimates over. And in this case we want to do estimates across the variable population. So I'm going to set spec equals population. So here is the emmeans command to set up the estimates, and I'm going to save that as an object m_eff. And then if you do a summary of that new object, it gives estimates of the log cortisol for each population separately. It also gives the standard error on those estimates, and it also gives 95% confidence intervals for upper and lower confidence levels. So already that's a useful report, but we can do better than that. We can back transform onto the original scale by specifying that a log transformation was used for the analysis. So we're going to update our object and add in a transformation. And there's several ways to specify a log transformation. One way is to call it a Box-Cox transformation with an exponent of 0. So that's what we've done here. So I'm going to create a new object that updates the old one, adding in this transformation. And then if I do a summary of that new object and I specify type equals response, it's going to produce a summary table where the effects are reported on the back transformed scale. So here we see population 1 is an estimated cortisol value of 14.1 with a standard error of 0.8. And it tells you at the bottom here, intervals are back transformed from the log scale. So these values now are just raw cortisol concentrations. And the 7 ways to doing the log transformation, we could have specified it as a power transformation with an exponent of 0. That would have been exactly equivalent. And emmeans has several quite built-in transformations that you can make use of. Right, so emmeans is a great package. It does lots of things. There's loads of details in the help for you to go away and explore.